Hi there, this is Mr. Hall, and this is a video on how you do rate of reaction calculations from graphs. In my previous video, I did calculations just from data and how you interpret graphs, but this is going to be a lot more about how you actually do the calculations from the graphs themselves. And there's a few ways of doing it, so it's important that you're aware as to how you do those different methods. So the objectives for today's session are to calculate the mean rate of reaction from graphs, just kind of straightforward mean rates of reaction calculations, and also how to calculate the mean rate reaction between 2 points from a graph. So before we sort of go into the graphs themselves, it's good for us to be reacquainted with what these equations are that you actually have to know. So the equations are as follows, and rate is effectively either the mass of reactant or product or the volume of reactant or product divided by time. Note that it's always divided by time. Now, one thing that I want to emphasize before I go any further is that you have to always annotate your graphs. Always, always, always annotate it. There's loads of good reasons for annotating. It's partly because the examiner likes to see it and they will give you marks as a result. Secondly, it helps you show your thinking, and it also will ensure that when you're doing questions, you won't make silly mistakes because you're annotating every step of the way to make sure that you get it right. So please always annotate your graphs. The number of students that don't listen to that advice and then just try and estimate it from their head and make mistakes it happens all the time, and it's really frustrating. But if you annotate, you're just minimizing any mistakes that could potentially happen. So we'll start with the 3 different ways of how you can calculate rate from a graph. Now, the first way is just the mean rate at a certain time, and that's probably the most straightforward of the 3 different ways. The second way, which is weirdly worth a lot of marks and it's actually quite straightforward, is to work out the mean rate of reaction between 2 points in time. And then finally, it's the instantaneous rate, and for the AQA qualification, that's higher tier content, and I cover that in a separate video. But I'm going to focus on the first 2, which is the mean rate of reaction that you have to be able to do. So for the first one, for that at a certain point, it's really straightforward. So if you are asked what the rate is at 3 seconds, you do the following. So you look at where 3 seconds is on your graph, and here it's between 2 and 4. So I know it's going to be around about there. Okay. So I'm just going to circle where 3 seconds is. All right. And I know that's what I need to look at. I then need to mark up to where 3 seconds is on my actual curve. So if I do a line going up, and I'll sort of make it as straight as possible, but it went very good, it's basically going to match up there. Obviously, when you do it, you're going to be using a ruler. Then you're going to do a line across to see where it intersects the y-axis. So I'm just going to go across, and I can see the value is 25. Okay. Now I need to use my equation, which I've used before, which is volume of product divided by time. So in this case, it's going to be 25, because that's at the top, centimeter cubed. I divide that by 3 seconds, and that gives me 8.33 centimeter cubed per second. Okay, so that's my first calculation. So it's still like volume of product or mass, whatever it is, divided by time. But the crucial thing is that you have to get the data from the graph. So let's try another example. Let's say I have to work out the rate at 6 seconds. So again, I find the first thing I do is I work out where that time is on my x-axis, which is here. So 6 is over there. I then have to see where 6 intersects on my curve. So I sort of do a line up, which reaches this point, and then I draw across as straight as I can, and it will hit there, which is 35. So now I've got the numbers 6 seconds and 35 centimeter cubed. I have to do volume divided by time. So I do 35 centimeter cubed, and I divide that by the time, which is 6 seconds. And that gives me, I think it's 5.83 centimeter cubed per second. Okay, notice centimeter cubed at the top, seconds at the bottom, and that dictates the unit I've got. Other thing to notice here is how the rate is actually decreasing over time, which is exactly what we would expect, because as the reaction goes on, the rate slows down. Okay, and let's say I was asked what the rate is at 9 seconds. Okay, so at 9 seconds, same procedure as before. I look for 9 seconds, which is here. I do a line going up to see where it intersects the line, which is there, and then I do a line going across, which is around about 39. Okay, and you can write the number it is there in case you don't have it. Okay, that's always a nice thing to do. And then I employ my equation I've used before. So I do 39 centimeter cubed, and I divide that by 9 seconds, and that gives me, I'll just put in my calculator very quickly. So it's 39 divided by 9 and that gives me 4.33 centimetre cubed per second. And again, that makes sense. You can see how the rate has gone from 8.33 to 5.83 to 4.33. The rate is going down, which is telling me that as the reaction proceeds, it's getting slower. It's exactly what I would expect. So that's the first type of calculation you might have to do. Now, there's a second type of calculation that might be given, and this type is more to do with between two different points. Slightly trickier, but not massively tricky. And if you're good at this bit, then the next bit shouldn't be that challenging. So let's say I was asked to find out the rate between, or the mean rate between 3 and 6 seconds. So the first thing I have to do is I have to identify where those two different numbers are on my graph, okay? So we did this in the previous one, so we know 3 is over here and we know 6 is there. I'm then going to do 2 lines up, okay? So I'm going to do one line going up to here and then going across. And just like before, we knew it's 25. And 6 again, I'm going to go up and across, which from my last example, you may remember is 35. I now have to find out the difference between each of the 2 points. Now, if you remember from the old equation, effectively what it is, it's volume divided by time, okay? And that gives me the rate, okay? That's what I kind of went through at the beginning of the video. What we're now looking for is the change in volume, which I'm going to represent by this Greek letter delta, as basically just means change, okay? So change in volume divided by the change in time. Now for this question, between 3 and 6 seconds, my change in volume is between 25 and 35. So I have to do 35, take away 25, and that will give me a number, which I'll do in a second. And the difference in time is between these 2 points, which is 6, and in this case it's 3. So I'm going to do 6 take away 3. So 35 take away 25 gives me 10. 6 take away 3 gives me 3. Okay, and that's 10 centimetre cubed divided by 3 seconds, which in this case gives me 3.33 centimetre cubed per second. So you can see that the calculation is really similar to what you did before. The only thing you have to be very, very sharp about is noting that you've got 2 different points this time and you have to work out the difference. It's like worth 4 marks or more in an exam. It's really straightforward to do, but just make sure you know how to do it. Let's try another one. Let's say we've got 3 seconds and 9 seconds. So I've done my 3-second markup already. I'm now going to look at 9 seconds. Now 9 seconds between 8 and 10, which is here, it's right in the middle. So again, I'm going to draw a line, which is right in the middle going up all the way to here. And then I'm going to draw it across. And if you remember from the last calculation I did with 9 seconds, that should be at 39. And in the exam, you'll get much finer sort of graph papery prints to work with than what I've got here. So don't worry about that. So again, I have to do my change in volume divided by change in time. Now this is between 3 and 9 seconds. So I've got 39 take away 25. So 39 take away 25. Now for time, it's 9 take away 3. Okay, so 39 take away 25 is 14, maybe? Yeah, 14. And I divide that by the change in time, which is 9 take away 3, which is 6, okay? So I do 14 take away 6, and I put that in my calculator, which is... Bear with me. And that gives me 2.33. And again, it's centimetre cubed per second. And that's how you do it. So that's how you do the second type of calculation when you've got between 2 different points. And that's how you do it. So I hope that's been useful. I'm doing instantaneous calculations on another video, so that'll come up. But best of luck with all your calculations.